Thank you, everyone. Thanks for staying around. I know it's quite late. It has been a long day already. And my talk will be super technical, so I hope you like it. My name is Dionysios Tsoumas. I'm leading the DevOps team at GWI. I'm very excited to be here today. And we'll speak about a topic I'm very, very passionate about. It's about chaos engineering, but I will speak a lot about chaos engineering, but mostly I will mean ownership of your services and observability metrics. It's going to be super fun. Okay, so let's do this. A few things about what we'll talk about today. First, we'll cover our stack, and then we'll say a few things about chaos engineering, mostly how we ended up here, and then we'll have a look into our tools, and then we'll see our tests and how we build our dashboards, and then we'll do a bit of gaming around our results. Okay, this is going to be a bonus slide. I wasn't sure if I should speak about what chaos engineering is, because it's been around for around like a decade, 10 years. But like in overall, in high level, it's just an approach to identify failures before they become outages. If you like the work proactively, we would like to test proactively how our systems behave under stress, and then we can identify and fix and iterate on issues before we get up in the news. And we literally will break things on purpose in order to learn how to build like more resilient systems. If you've never heard about this term, the easiest way to think about it is I have my Kubernetes clusters and I automatically, like on purpose, do out-of-memory kills just to see what will happen. And then we have loads of similar tests like that. So we want to proactively, on purpose, add small chaos experiments in our workloads so we will see what will happen proactively before really bad news starts to happen. Okay. Our stack is a lot, right? Okay. We will focus on the monitoring and observability stuff in there. We are having Prometheus operator, whatever this includes. It's not only Prometheus, it's the operator. So it has like black box exporter, it has alert manager in there, and other stuff. We're having Thanos that is responsible for aggregating all those Prometheus instances. And then we have Grafana, good old Grafana. We have like many things in there. We're using loads of Grafana stack, including Grafana itself. We're using Loki for logs, Tempo for traces. We started using Pyroscope lately for profiling, but we also have K6 for monitoring, for performance metrics when it comes to our QA. And then we're having OpsGenie. It's not by Grafana, but this is where our on-call teams are getting notified. And this is for the monitoring and observability. For the rest of our stack, things are not something very special. Loads of Kubernetes clusters on Google Cloud. We're having GCP monitoring for fallback. And then we're having Sentry just to check out our errors. And then LinkerD and Chaos Mesh. We will talk about those things in a bit. So a lot of things. I say a lot of things again and again because this is important, because we need our engineers to be at least own this kind of stuff so they know what we're talking about. Okay, and it's a lot of things for them. Okay, but how did we end up here? Is chaos engineering still relevant? It's been around for 10 years now. And many companies, were joking around and say that they're doing chaos-driven engineering either way. And like a member of my team said, we don't need like extra tools for this. Chaos is baked in our infrastructure either way. But jokes aside, it's not the first company, it's WI, where we're trying to implement this kind of principles. Okay, and it's important to understand what we did different this time. And we did a few things differently. First of all, we got people passionate about ownership. And our engineers owned their services end-to-end, from writing code, writing metrics, observability, on-call, infrastructure as well. They own everything. And with this culture, we motivated and people are become obsessed with it. And then ourselves, we become obsessed with observability metrics. We wanted people out of the box to have access to as many metrics as possible. And then we wanted to scale this as well. But what really helped us enable those chaos engineering experiments was the introduction of service mesh, which we'll talk about this in a bit. Okay, something that we also introduced that we're not very proud about, it's called death by thousands of microservices. We have loads and loads and loads of microservices. And people are very clever, and it's easy for them to understand that we have few services in there, and if my login service goes down, it will probably affect our users, okay? And the services will be down, people will not be able to log in, and then we'll start having an issue. People get that. It's very surprised, though, when they find out that our bundle service, which is near the end of our stack, if this goes down, then this also affects our users because the login service will stop working. And they are surprised when they find out these things, these interconnected dependencies. Now, if this is familiar, imagine how this will look if you have 5, 6, or 10 microservices down the road on your platform. So what we wanted to do is we wanted to identify these bottlenecks. We wanted people, product, to see what we talk about and identify, fix, if it's easy to have an easy win, and then iterate and move on with our lives. So what we did is we introduced a couple of days per quarter, which we call Bring Your Chaos to Work days. And each quarter we are trying to do different things. It's a playful event, even though it's not, it's kind of serious. So we implemented this last couple of quarters, and we started by something very simple. We said, we'll do chaos experiments on our staging cluster, a whole day. If everyone wants to join, come in, and then we'll try to break things. So that was very interesting. And then the following week, we did something similar for production monitoring, which sounds more serious. So the whole DevOps team was down, and then the whole day we tried to bring down our monitoring suite in production. And now we'll mostly focus on the monitoring part because it's the most interesting thing. And also possibilities were endless. So we wanted to answer stuff like, what will happen if my login service is down and my Prometheus server is flaky as well? Will the on-call team ever get notified? What will happen if my Prometheus is down, but also my Loki server is down? Will the engineers, the DevOps engineers, be able to figure out logs? Where will they find them? If we have multiple outages, it doesn't have the whole service to be down, flappiness, nodes are down, latency, error rates, and then this also affects our monitoring suite. What's the average response time for our engineering, on-call engineers? These were questions that we knew that maybe were not extremely good, but we never had answers. What will affect? How long will it take to bring stuff up and stuff like that? So yeah, that's what we did. We tried to bring the whole thing down, production, based on small experiments that we'll see in a while. Then we kept notes, we made it fun for everyone, and then based on the results, we iterated and we fixed stuff. Now, a few words about LinkerD, because we wouldn't have been able to talk about this kind of stuff if LinkerD was not in place. Now, this will not be a service mesh talk, but LinkerD enables us to have out-of-the-box metrics for everyone in GWI, at least when it comes to the golden observability stuff. Golden observability stuff, it's latency, saturation, throughput, error rates, stuff like that. Some people were passionate about and have built it themselves, but we really want to go all the way through. Every engineer for a new microservice will have nice Grafana dashboards with all those metrics out of the box. And the service mesh enables these kind of things. So when we have them, then the next question is, how can we use them? How can we make people, at least, they know that these things are there for them and how can they use them? So this kind of playful events, it's for them to get familiar with our tools and practices. And of course, Chaos Mesh. If you've never heard about Chaos Mesh, it's an open source CNCF project that allows loads of similar chaos engineering experiments to happen. It has very good support with Kubernetes or with loads of cloud providers. It has a very nice UI that you can monitor your experiments. You can add them through the UI, or you can put them in a cron job and then run them. It wouldn't be possible to run those kind of stuff without Chaos Mesh. There are other solutions. This has been completely amazing. Be sure to check it out. Okay. And then a bit of preparation work. We'll talk about our tests. We already talked about Chaos Mesh and about LinkerD. So we ran 4 different cases for each component. Now, we had a whole day to test out stuff, all right? So we said that in a whole day, we could have 5 or 6 or 7 components that we can test out. And for each component, we run these 4 different tests. We stressed out pod failures and network delay. This came by the chaos mess. But we also want to experiment with LinkerD and fault injection. This is tricky because obviously chaos mess can also do fault injection. But if you have engineers thinking with fault injection in mind, then the next thing they can do is, okay, you know what? I can use A/B testing instead of fault injection. You'll see in a bit. Okay, so we have a peek in our tests. Of course we should. Let's see if this will work. Yes, it will. All right, this is our repository. So for our first day, we have run experiments in our alert manager, Prometheus, in our Grafana stack, Karma, Prometheus, distributor for Tempo, and Thanos. Loads of things. We'll try to bring down like loads of stuff. Let's have a look in alert manager. If internet does not fail us. Okay, just a bit slow. So let's see, pod failures. Now this is from Chaos Mess. It has its own CRDs, just configuration. You don't need to understand exactly what is happening. The interesting thing is here. You just have this thing running in your cluster, and then what it does, it says, I will run this test, and then I will wait for a minute for my sister to recover, and I will add something different, and then I will wait for 1 minute, and then something better, and then I will wait 1 minute, and stuff like that. Now, this is where we define our stuff. Again, we don't care how the configuration looks like. Chaos Mess has some amazing documentation, so it's like a couple of minutes work to read and understand what is happening. But let's see, for example, just one here. All right, so in this specific, we just kill pods. We kill 25% of pods, and then we're waiting for a minute to recover, and then we delete 50% of pods, and then we wait for 1 minute to recover, and then 50% of pods, and then the pods are properly going down. Now, because this was production and we have high availability, it wasn't that much. Pods are being killed all the time, okay? But we wanted to see what would actually happen when we had combination with platform outages. So this is an example of how the pod failures looking like. Similar is a stress test. Stress test mostly does out of memory kills and CPU throttling. That was also very interesting. For example, if you're having Prometheus throttling and then you are like debugging for a production incident, is Grafana working? Is Thanos working? If Thanos is having throttling, can you be able to debug everything when you really need to do these kind of things? We didn't know this kind of stuff, but now we could test them. Again, very easy configuration. The most difficult part, and this is where it's getting interesting, is the fault injection things. These are coming from LinkerD, the service mesh. Now, if you're not familiar with LinkerD or with service mesh, it doesn't matter. What we're having here is just a config map, Kubernetes config map. It's easy, just have like a simple Nginx configuration. Then we define a new deployment. This is our Nginx deployment that just uses this Nginx image and loads the configuration. Then we have a service that points to the deployment we just created. And all the work is being done through here. We are having an HTTP route, which is a LinkerD custom CRD that basically says, I have my alert manager service, just do split traffic. Send 50% of traffic in the proper alert manager deployment, and the rest to my Nginx service that I just created, which will always fail. This is proper A/B testing, okay? It doesn't matter if we use it for chaos engineering or for feature flagging or for A/B testing, it doesn't matter. This is what the LinkerD is very good at doing. And when we implemented this, it basically means that half of our requests to alert manager will fail. And we want to see how our system will behave. Okay, so if you remember here, we also said about network delay, and we have tested this out. but we have mixed results with LinkerD. Because LinkerD exactly what it's doing is like it's putting a container into every pod that is possible for inbound and outbound traffic. Chaos mesh network delay, it was one layer below, so it was not working properly. Okay, but we could also fix it. We could remove temporarily LinkerD and then test it out, or we could do it through the LinkerD, which already has. LinkerD and Chaos mesh, they interconnect. They are doing some similar stuff. Okay, and then prep work, dashboards. We obviously have a lot of dashboards internally. We wanted to create one specifically for our chaos engineering days. It's not very fancy. We just combined like a few different data sources. Mostly we were interested in the metrics coming from LinkerD that has to do with throughput and with inbound traffic. But also we wanted to have one way, an easy way to see errors. Error log aggregator which is coming from Loki. Now, that was just for fun. Eventually, when you are aggregating all your results, you have all the time in the world like to view your existing dashboards and see what's happening over there. And something else about the event as well, like in this kind of events, you want people to participate and be engaged. You just don't want to just watch an empty screen. So we want to make it a bit more playful. We just assigned roles to the whole team. We had like someone responsible for keeping notes. That was the chronicle. We had like someone for keeping track of alerts, responder. We had 2 people who were responsible for having everything up and running. Those guys were our maestros. We had a firefighter who was responsible for handling communication for the product, users. And then we had a watcher who was monitoring for all errors. Then we put all those people inside the war room for 2 days, and then they were just throwing stuff at each other. And they were also responsible for keeping notes, obviously. It was a lot of fun. Now, a quick question, something that we weren't very sure. Like, is it worth emulating users? Because in our experiment with staging, obviously you don't have loads of traffic over there. So when you're running your experiments, how can you know the actual impact since there are no users in there? Chaos engineering as a principle, eventually it requires to constantly run those experiments day to day in your production cluster in a small scale. Okay. In our case, we didn't do that. We just had the whole days of running into it. So we could emulate users. We could take our K6 scripts that we're doing performance metrics, scale them down a bit, not to have like so much traffic, so many users, and then we could constantly run them. This is what we did. So staging was constantly having a small amount of traffic coming from the K6 scripts that have stuff that QA have written for us. For our monitoring, we didn't want, obviously, not many people would browse Grafana at the same time, so it didn't make sense. So my answer is maybe yes, maybe no, depending on your criteria. Ultimately, I want my stakeholders, the product, to have dashboards, proper data to showcase what is actually happening in case of an emergency. But sometimes, having a blank screen saying, you know what, if this fails, the service, it looks like that, it's just a black screen, it's a strong feeling, okay, it's a strong signal enough to justify that something needs to change. And as we're getting like close to the end, just let's have results, an interesting piece of information. What did we learn out of this? So, introducing the results, let's play a game. So let's say everyone here is a GWI engineer, and we are very passionate about what we're doing. We think that we have very good observability standards. We know our stuff. We feel confident that things will go, up to place. And I will ask a few questions. So raise your left hand if you think it's A, or raise your right arm if you think it's B. And then let's discuss a bit about our results. So how many P1 alerts you think we triggered? Left hand between 0 or 5, right hand between 6 and 15. What do you think? How many do you think we raised? Okay, all right, okay. I would say the same. Unfortunately, we got just a single P1 alert. And we're talking about production monitoring, okay? Now, the alert we got, it was good old Prometheus. Prometheus instance is down. It's serious enough to justify an alert, which makes sense. But then a few things, obviously, they're not working out, okay? What it means for us, it means that P1 alerts are a bit too flexible. Obviously, we should have raised more than that. And something I didn't mention is that our tests were running for 10 minutes. So after 10 minutes, they just stopped, and then we allow a bit of time for the system to gain back its health, and then we're running something different. So obviously, our P1 alerts are a bit flexible. This should change. It also means that our tests were not aggressive enough. Maybe 10 minutes, it's not enough. Maybe slowly getting pods down for a system that auto-heals and it's highly available. It's not a lot of damage. Okay, so maybe our system, maybe our tests should be more aggressive. Bring everything down, and let's see what happens. Okay, so it's not. I would also expect to get more P1 alerts, but maybe it's not that bad because it's a signal that auto-healing and high availability is working all right for our case. Okay, but it was a bit alarming. How about P2 versus P3? How many P2 alerts you think we got versus P3 ones? You think more P2 or more P3? Interesting. So we only got P3 alerts. I was mind blown. And what's even more interesting is that those P3 alerts came from LinkerD. And actually LinkerD was saying, you know what, most of the traffic I'm getting, I get a lot of errors. Please have a look. Which, it's us caused it because we said X amount of traffic will fail. Okay, so those alerts were expected. Now the interesting thing is that only LinkerD stuff, which you can imagine what would happen before we introduced LinkerD. No alerts in there. So it was alarming because even though we felt that we were good at something, eventually the only system that let us know that something is wrong is the thing that is the last piece of code we have implemented in our cluster. And loads of action items would came out of this. Actually, they came out of this. At least for the monitoring namespaces, because we're testing monitoring, we changed P3 alerts to P1 and P2s. We wanted to be confident that the next time that we will run those results, actually by the end of this month, we want to get notified not as P3, where people tend to ignore, especially on busy days. Let's get P1s. And then let's see how busy we'll get. If it's not very busy, that's fine. If it's very busy, then we'll iterate again. Last one. What about P2s? We haven't said anything about P2s. Do you think we didn't have any P2s, which, that's something? Or we have eventual consistency. So eventually we may get some P2 alerts. What do you think? Left or right? No P2s or maybe some P2s eventually down the road. This is very interesting. So eventually we would get some P2 and P3 alerts, which is very dissatisfying. What it means is that we gave ourselves the ability to fine-tune the alerts so much that we didn't want to bother our engineers a lot. So we said, you know what, it's fine. For 10 minutes, it's not that much. Out of memory for pods for 10 minutes, they can wait for a bit. So we would get eventually some P2 alerts, mostly on out of memory and deployments, not having enough replicas and stuff, but in 20 or 30 minutes, which obviously this is a problem because you can have a problem in production, in your monitoring, and the on-call engineer will not get notified in the first half hour. And even this, at this time, it would be a P2 or even worse, P3 alert. Obviously, this is not okay for us. Those alerts are coming in place from the past. So, people were not very anxious if karma was down or if testing or staging was down. But it also affected our production, okay? And this needs to change. In our case, we have fine-tuned everything, at least in the monitoring namespaces, to be much more aggressive. We want our engineers, the DevOps engineers, to know faster if something is wrong. Even if this something is wrong, it's Prometheus pods getting out of memory or getting a lot of errors. Now, our biggest finding, however, it didn't come out of this. It came out of our platform staging day. Because we fine-tune alerts, and it's fine, people are fine-tuning, teams are fine-tuning alerts all the time. But what is very, very interesting is how we can use LinkerD's way of timeouts and retrying mechanisms to fix all those stuff. So we try to answer the question, okay, what will happen? How is the easiest way to fix failures, out of memories, requests? And obviously we need to retrying. We need retrying mechanisms. But when you have the death by thousand services, like so many microservices that you need to upgrade and fine-tune for retryings and timeouts, eventually it's taking like ages. It can get like an engineering team of like 6 months to do this. LinkerD allows this like automation out of the box. So we can say for our specific services based on certain policies, we want to do 2 retries. And with timeout backoffs, it's fine. This means that if we're having a latency, it's fine, it will retry. And then our experiments will pass. Now, if we have a big incident, obviously it will be an issue, and the retry mechanism needs to not try indefinitely, okay? But an amazing finding out of this is that people were eager enough to do the minimum work of adding LinkerD's retry mechanism for their namespaces, and then out of the box, in the next iteration of those days we'll have this month, hopefully we'll see, did it fix the issue? We hope that it will improve it a lot. Was this the case? Maybe not, maybe we caused other issues and stuff like that. So that's it, I think, yep, close to time. It was very interesting. Eventually we want to go down to a route where some of those stuff run very, very often, unexpectedly. We don't want our engineers to be on hold and to see what is happening. We're not that far away, but before we get there, we want people to get familiar with these kind of things. So if you want to get something out of it, is observability is the key to everything. People, if they have metrics, they're very eager to use them and show how they can make their services better based on that. Thank you.
Anyone questions?
After you changed the categorization for the alerts, did that incur any additional workload for the engineers while they are on call? Did they got waken up a lot at night or much more than before?
No. These alerts affected the DevOps engineers. And people tend to change stuff when they don't like. So actually, this is alarming. I would expect people to worry a bit more. We didn't get any more on calls during the night, but as I have said, those systems, they're resilient either way. And we would like to be, so what's happening is you fine-tune an alert, it's a bit aggressive, and then people complain, and then you give them a bit more slack. But we're getting to a point where giving a bit more slack means you have a production incident for half an hour and no one knows about it. It's a constant battle, okay? You need to constantly iterate, and this amount of stuff, they tell you what, how confident you feel like in your team or in your company to get notified. The answer is no, but so this means that we can get better. So we can get a bit more aggressive, okay, to get to the point where people are not, are close to be familiar with how often things are happening.
Right, and a follow-up question. When a P1 is raised in the middle of the night, what is the typical remediation? Is it changing the size of a pod, restarting a service, or is it more like code changes that are required?
All right, we have multiple on-call teams, so we'll talk about the DevOps one. I think it's like 15 minutes, and since we don't have SLAs like to our customers, I think it's fine. Most of our P1s have to do with services be completely down. So we're using black box exporter, and we're also using case 6 to do some performance metrics to our services. So if something is P1, it's really serious. Okay, but we don't have that many incidents, hopefully. But yeah, it's 15 minutes.
Thanks.
Nobody else? Really? Okay, then thank you.